Alright, so this is section 2.6, proving statements about angles. Some students get a little intimidated by proofs, and what I would tell you is that we don't ask you to come up with a proof on your own. We mostly will ask a proof that is very similar to proofs that we've already done. So if you have a good memory and if you can do your best on these proofs and to memorize certain parts, there's always points that you can get. And then we ask the same type of proofs. So if you can kind of memorize, not each individual proof, but kind of memorize some certain statements and how they connect together, it makes it a lot easier. So I would encourage you just to do your best and to keep trying, and as you do that, it should get better. Okay. Also, as you're doing the video notes, if you could try to do them in advance, and if you're having trouble, you can maybe use orange, an orange highlighter to highlight stuff you want to ask questions about. So if you get lost at a certain point, highlight that in orange, and then come to office hours or ask in class, and we can work on that some more. Okay, but let's get started here. So a theorem is a true statement that follows from a result of other true statements. Okay, properties of angle congruence. We've already talked about other properties, these properties with respect to line segments and equality. So this should not be a big deal. It's connected to stuff we've already learned. The reflexive property for any angle, the angle is congruent to itself. That seems silly, but we're actually going to see that in action at some point. Symmetric, if angle A equals angle B, then angle B equals angle A. We can flip them over. And the transitive property of angle congruence, much like the two that we learned about before this with segments and equality, if angle A is congruent to angle B and B is congruent to angle C, then we can kind of just bypass the middleman and we can just say that angle A is congruent to angle C. All right? All right, so let's get into this proof here, and we're looking for certain things. When we put these on tests, we try to help you out and organize it a little bit better as far as when you should use this given information. Now, technically, you could use all the given information at the same time, but we really like it to kind of go step by step. So we want to try to piece this together and see. So here's something we can do right away. So our last statement that we're going to make is going to be what we're trying to prove, and that's always the case. So we're trying to prove that angle 1 is congruent to angle 4, so we can put that on here automatically. So that's a free point. That has to happen. Now, another thing that has to happen, and we can draw this arrow down here. I don't know how many arrows. I'm going to get a lot of arrows going here probably, but so we can draw that arrow there. Now, our first reason is almost always, I can't think of a case where it's not, going to be given. Some information that we were given that we're going to use to say other things. So those two spots should always be free points. Now, when we look up here, I like to go in order, and so I would like to start with number 1 if I could use this at all possible. Well, I see that I have these two here. I highlighted them in pink. They kind of go together. 1 to 2, 2 to 3. That's kind of what we have up here right there. Okay, so I'm going to start off with angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. All right? So that is free points also. Like I said, if you were stuck, you could put all 3 of those things there, and you've got 3 out of 8 as a minimum. So that's just flat out memorization. Now, the next thing we would do is, can we use this statement to make another statement? And yes, hopefully we can. So we could say yes. We could say angle 1 is congruent directly to angle 3. And we have that up there. That's the transitive property of angle congruence. All right. So that's good. Now, if we look up here, I want to get rid of all that stuff. So we're just looking at this. So now we want to ask ourselves, well, there was another piece of given information that we didn't use, and that piece kind of connects pretty nicely to here. So we could also say angle 3 is congruent to angle 4. That's kind of coming down here. And that was also given. And then now, sometimes what we do is we take the two previous statements and say, do they tell us something about the next statement? And yes, they do. If we combine those two, we say 1 to 3 and 3 to 4, so we can go directly from 1 to 4, and that's the same reason as number 2, the transitive property of angle congruence. All right? So you just want to keep battling with that and go through that on proofs and do the best you can, and they should get easier as we go. All right? So hopefully you should pause the video right now and you should fill in 3 out of the 10. You should be able to fill 3 out of the 10 based on the last problem that we actually did. So the first thing I would do probably, so hopefully you paused and you came back. I'm trying to prove the measure angle 4 equals 63 degrees. And here we had some given information, but hopefully, like I said, these two kind of look like they go together. This one, maybe I could do something with that, but this flows pretty nicely. So I'm going to say, actually, angle 1 is congruent to angle 3. Angle 3 is congruent to angle 4. That's coming straight down here. And this one should have been automatic. That's going to be given. Okay? So that's given. So that kind of goes over there. Now again, so this is what I'm talking about. When you say, well, some people, oh, proofs are hard. Yeah, the parts of them are. But we have literally done this 2 times already, and this is the 3rd time. So it's the same thing that's happening up there. So we're going to say angle 1 is congruent to angle 4, and that's where I'm talking about memorization coming in to help you. Memorize. So again, we have the transitive property of angle congruence. Okay? And now, here's something to think about. So here, you see that those are congruent. Here, you see something's equal. Okay? So if in a proof something changes from congruent to equal or equal to congruent, then that has to happen somewhere. And so I can see that angle 4 is equal. I might as well do that right now. So I'm going to say the measure of angle 1 is equal to the measure of angle 4. You might say, well, how did you know that? Well, I know that it has to change from congruent to equal somewhere in between here, because it was congruent and it ends up being equal. So I just decided to put it right there. Let's take care of it. Now, when you switch from congruence to equals, that's the definition of congruent. And that works either way. So if it's equal and we make it congruent, that's the definition of congruent also. Definitions are biconditional statements. It works either way. Okay? Now, the next thing I have here is I've got this other piece of given information that I haven't used yet. So I'm going to say the measure of angle 1 is equal to 63 degrees. And that was given also. All right? And now, oops, I left that 1 off there, the measure of angle 1. So now I have this angle is equal to this, and we have these two are equal to each other. So what we can do is we can combine these to give us this. So we have the measure of angle 4 equals the measure of angle 1, and the measure of angle 1 equals 63, so we can go directly to here. Now, this is a little bit tricky. It's going to be the transitive property, but these are equal signs. It's going to be the transitive property of equality. Okay, so that's a little bit different. I just want to go over real briefly the difference between the transitive property and substitution. So the transitive property of equality is if A equals B and B equals C, then A equals C. You just kind of get rid of that. Now, substitution is a little bit different. So substitution, we might have something like A equals 3B, and over here we might have A plus 5B equals 10. And so here we're actually replacing A with this right here. So that's substitution. We took the A out and we replaced it with something else. So those are very similar, but notice this is usually just one to one, 1 to 1. All right. So on the next page, our textbook organizes theorems based on numbers in the chapter. So 2.3 means chapter 2, third theorem. That's the third theorem they've talked about in chapter 2. But those numbers are not that important. They only relate to our textbook. So a different textbook might have these in chapter 3, and so they might name this 3.3 or something like that. So we don't really go by these numbers. I just have it so you know where to look in our book, but it's not really that helpful. The main idea is this, the right angle congruence theorem, and so we could call that the right angle congruence theorem. We want to shorten that stuff up. We don't want to be writing all of that out. So over here, so we can either use the name or we can use what it says. So here I would say all right angles are congruent. So that's probably what I'm going to use because I just think it's clear and to the point. All right angles are congruent. It kind of says what's happening. Okay, so to save some time, I already put some of this information down here. So that was that given information right there. So after a while, we might fill that in for you on a test because it is free points. So we're going to give you free points for a while, and then eventually we might start filling it in for you to save time. And there's that proof statement that we were talking about earlier. So those are the ones that I like to call free points. Now, so that is just memorized how to start this thing off. Now, we want to take this, and does that tell us something? Does that give us another piece of information? Well, if DAB and ABC are right angles, then that means they are congruent to each other. So angle ABC is congruent to angle DAB because all right angles are congruent. All right. Now, back to this up here, there was another given piece of information that we haven't used yet, so probably that'll be down here. So angle ABC is congruent to angle BCD, and that was given. All right. And now, if we take these two things, do these two things tell us something? Well, this is congruent to ABC, and angle ABC is congruent. So this to this and this to this. We've had that before, so we can go directly from here to here. So again, this is about the fourth time today, the transitive property of angle congruence. Okay, so it's kind of that memorization and how do those things work? You just keep going with that. Now, congruent supplements theorem. If two angles are supplementary to the same angle, so let's think about what that means for a second. So I'm going to just sketch this. Probably should have used a protractor that would have been a little bit straighter there, but I'm just going to make this up. So let's say that's 150. And then let's say there's an angle here. And let's say that one is 30. And we're going to put one more over here. And that one is 30 also. So it says if two angles are supplementary to the same angle. So these two angles are supplementary, because we all remember that supplementary means 100 adds up to 180. And these two are supplementary. So that means these two must be congruent, because that's not changing. So if these two added together equal 180, and these two added together equal 180, well, that was the same both times, so those must be the same size. So that's all that's saying. Congruent supplements theorem. So if I was going to name that congruent supplement theorem. And then the complement that kind of should make sense too. So if I put a 60-degree angle in here, and these are complementary, and these are complementary, then those must be congruent to each other. All right, so let's try into proof. So we're giving you free points on this one. So go ahead and try to get some of those free points. Pause the video. Ready, set, go. Pause. All right, I'm pausing while I'm thinking that you're paused. So I'm going to start with this. Actually, I might throw this in here also. So that's going to go here. This is going to go here. So pretty much automatically we want to put that given right here. So hopefully you're getting a little more comfortable with that. You're memorizing that given goes there. Here, this makes a nice first statement, so that's what I'm going to use. Hopefully you can see where we're going to go with that. Okay. So, and then down here, trying to prove angle 2 is congruent to angle 4. So there's several things in here that we've already talked about in the other proofs, so you want to connect those things together. So we want to start by going from here to here. So this is 24 and this is 24, so those must be equal to each other. A equals B and B equals C, so A equals C. Now, that's equals. So even though it's talking about angles, it's some of the measures of the angles, and those are numbers, and that's equality. So that, and you could pause each time here. You want to pause when I write the statement and see if you can get the reason and build it that way. So the transitive property of equality, because they're numbers. Okay? Now, at some point between here and here, look at what's happening. Now, again, I mentioned this earlier. So we have an equal sign here. But we end up with a congruent sign. So somewhere in between here and here, we need to switch. So we might as well do it now. So we're going to say angle 1 is congruent to angle 3. And anytime we have a switch, either way, that's the definition of congruent. So you just memorize that. And we should have been looking for that because it changed from equals to congruent. Okay, now there was another given piece of information, and it's kind of big, and so you can see we skipped a line here. So that is going to go there. And that reason is going to be given. Okay? I don't particularly want to write that out, but 1 and 2 are complementary. 3 and 4 are complementary. Okay. So, if we take the fact that 1 and 3 are congruent, then that means that these two are the same size. So if 2 is complementary to 1 and 4 is complementary to 3, but 1 and 3 are congruent, so they might as well be the same thing since they're congruent to each other. So since they're both congruent to the same size angle, or complementary, sorry, they're both complementary to the same size angle, that must mean they're congruent to each other. And that's the congruence complements theorem. Okay? So again, this is only in our book, Postulate 12, only in our book. This isn't called Postulate 12 in the world. It's just Postulate 12 in our textbook. It's the 12th postulate that's been mentioned in our textbook. If two angles form a linear pair, then they have to be supplementary. So hopefully that's pretty clear to everybody. If two angles form a linear pair, they have to add up to 80 because they form a straight angle, which means that those added together equal 180. And vertical angles, so this is vertical angles are congruent. This one is the linear pair postulate. So hopefully that's pretty obvious too. If we have an x, these two angles are congruent and those two angles are congruent. Okay? So that is it for the new notes. Now we are just reviewing. So these are some review questions to help you get ready for another test that'll be coming up. So what we did is we just copied some questions off of a test and put them in our notebook so that we could practice. So let's go ahead and do that. So it's telling us to write the contrapositive and the inverse of the conditional statement. Determine if each is true or false, express in symbolic notation with P and Q. Okay, so first of all, when we see the word when, we want to change that to if. Okay, no matter where it is. So it's possible that when could be in the middle, and then we would put if right there. And if we were starting with if right there, then we would go across here, and then this would become our then. So wherever when is, that's where the if starts. Okay, so the contrapositive. So first of all, I'm going to do the contrapositive symbolic notation. The contrapositive symbolic notation is always going to be not Q, then not P. Okay, remember the conditional statement up here is P, arrow, Q. That's your conditional statement, if then. Okay, so let's go ahead and do that. So the contrapositive means to switch these and say not. So if two angles aren't supplementary, then they don't form a linear pair, or then they aren't a linear pair. So there's different ways to phrase that a little bit, but so if they're not supplementary, then they can't be a linear pair. Well, yeah, because if they don't add up to 180, then they definitely aren't making a straight angle. So that's true. All right, so that's that. Now the inverse is the negative. So the negation, so that's the negative of P and the negation of Q. So if we negate this, that would be if two angles are not a linear pair, if two angles aren't a linear pair, then they aren't supplementary. Then they aren't supplementary. Okay, so think about that for a second. So they're not a linear pair. They can't be supplementary. We just had an example of that earlier in the notes. when I had the 150 and the 30. So there's 150, and over here is 30. Okay, so these two angles, that's an approximately. So these two angles are not a linear pair because they don't form that straight line. They're not adjacent. They're not sharing a side, but they are supplementary. So that's false. That's not true. All right. True or false? The following statements. So these are test questions. This is actually, we just had this on a test, something like this. So, true or false, the following statements are point-line plane postulates. If two planes intersect, then their intersection is a line segment. Well, it looks like that. We could look at where the front wall intersects the ceiling, and it goes across there, and it looks like a line segment going across. But you have to remember that plane goes on forever, so we have to imagine that the front wall continues out into the parking lot and up into the sky, and it keeps going. And the ceiling, we have to imagine it keeps going. It does keep going for a little while this way, but we have to imagine it keeps going. And if those planes, if the front wall and the ceiling went on forever, then that line segment where they meet would go on forever. So actually, it's a line, not a line segment. So that's false. If 2 points lie in a plane, then the line containing them lies in the plane. So if I put 2 points on here, on this piece of paper, and I connect them with a line, well then obviously that line is on the piece of paper also. So that's true. And through any 3 non-collinear points, there exists exactly one plane. So the key there is non-collinear. So by putting 3 non-collinear points together, that basically makes a triangle, and any triangle pretty much is going to be in a flat surface. So that's good to go there also. Okay, moving right along here. Write the converse of the true statement. So telling us this is true, write the converse. If the converse is true, write a true biconditional statement. If the converse is false, give a counterexample. Okay, so the converse. If 2 angles are complementary, so the converse is change the order. Change order. Now, you might say, well, contrapositive starts with CO as well, change order, but contrapositive is the longest one. So I remember when I have a contrapositive, I have to do both. I have to switch them and make them negative because contrapositive is the longest word. Converse, I just need to change the order. So I need to put if 2 angles are acute, then they are complementary. All right. Oh, symbolic notation. So converse just means flip them, so that's Q arrow P. Now, if 2 angles are acute, they have to be complementary. That doesn't sound right. So I think it's false, but if it's false, we should be able to come up with a counterexample. So 2 acute angles that are not complementary, because I'm trying to show the counterexample. So how about 11 degrees and 23 degrees? Those are both acute, but they are not complementary because they do not add up to 90. So that was false. If it was true, then I would have written this, and I would have put if and only if in the middle, and I would have ended with that. All right, last one for today, review question here. We have the syllogism and the detachment, the law of syllogism and the law of detachment. So a syllogism, remember, is what are we looking for? We're looking for a beginning that equals an end, an ending, a beginning that equals an ending. That's how we use the law of syllogism. It's really similar to transitive property, actually. So as I look through these lists of things, these are not if-then statements. So I'm not even going to look at those for syllogisms. Syllogisms are if-then statements only. So whole number, and I see whole number over here. So here's a whole number, and here's a whole number. So that means they're going to go together, and what I'm going to do is we're going to put those together. And so if it is, oh, no. that part is going to cancel out, and what we're going to put together is the part that's left. Just like in the transitive property, we bypass the stuff in the middle. So if it is a counting number, then it is an integer. Okay? Now, for the law of detachment, we're looking for something that's detached at the beginning. Okay? So we're looking for, so first of all, it's not an if-then statement. We're looking for something that's detached at the beginning. So we look over here at integer, that's not at the beginning. A real number, that's not at the beginning. Okay? Not at beginning. It's not at the beginning over here anywhere. But this one, a whole number, that is at the beginning. So when we find something at the beginning, then the answer is the end. Example I like to use, if you clean your room, then you can go to the movies. You cleaned your room. Then you can go to the movies. That's the answer. You can go to the movies. So here you have a whole number at the beginning. So the answer is, it is an integer. It is an integer. All right. There we go. Have a good day.